In today's video, we are going to solve a classic coding problem called two-sum. This problem is often asked in coding interview at companies like Amazon, Google, Microsoft. Now, let's start by understanding the problem statement. Given an array of integer nums and integer target, return indices of the two numbers such that they add up to target. You may assume that each input should have exactly one solution, and you may not use the same element twice. You can return answer in any order. And this is the problem statement. Here, we discuss the two approach of this problem. First, we discuss the brute force approach, and then we discuss optimized approach. Let's see brute force approach. And this is basically how to approach, how we think brute force approach here. First, take take each element of the given array, and we will try to search for another element such that its sum is equal to the target. And if such two numbers exist, we will return the indices. And what's the approach of this problem? First, we will use a loop, say I, to select the indices of the array one by one. Then, then for each index I, we will traverse through the remaining array. Say I plus 1 remaining array using another loop, say j, to find the other numbers such that sum is equal to the target, and then return the indices. And this is basically a brute force approach, and the time complexity is here. Here time complexity is of n square because we use two for loop. So we next discuss the optimized approach of this problem. Optimized approach is if we use HashMap, then let's see how we approach the optimized approach. Here, here we define a class solution which contains two two sums, contains two function two sums. The function two sum takes two parameters, nums and target. Nums is basically reference to a vector of integers, and target is an integer which is the target sum we are looking for. How we approve? First, we initialize the hash map. First, we initialize the hash map by creating an unordered map called MP to store each number in the array and its index. Then we iterate through the array nums and store each number. Then we iterate through the array I less than nums dot size I plus plus MP of nums of I equal to I. Okay. Then we find the complement for int I equal to 0, I less than nums dot size I plus plus, and complement is target minus nums of I. Then we check if mp dot of complement not equal to MP dot and MP of complement equal to I, not equal to I, then return I comma MP of complement. And next return input. Here, here we added through the array nums and store each number and its index in the hash map MP. Then we added through the array again. For each element, we calculate its complement by subtracting the current element from the target. Then we check if this complement exists in the hash map and if it is not the same element. Ensure we are not using the same element twice. Then we find such a pair, and if we find such a pair, we return the indices of the element and its complement. Now run this code. Let's see. Yeah, it's accepted. Now submit the code. Yeah, it's correct. And the time complexity of this approach is O n. And we and before we previously we discussed the brute force approach and time complexity of this approach is O of n square and optimize and the time complexity of this approach is O of n. And that's it. We have successfully solved some problem. That's it.